Hello and welcome. My name is Greg Johnston and I'm with Sensors and Software. My purpose today is to show you how to use the Echo Project software for visualizing and analyzing concrete data collected with a conquest system and generate reports. In other words, create high-end deliverables that provide more value to your customer and ultimately make you and your business more money. So let's get to it. First, I'm going to start off by opening Echo Project. The first thing you're going to see is the Getting Started screen. The Getting Started screen allows 5 different ways of opening data in Echo Project. The bottom 3 options, Add Grid, Add All Lines in a Folder, and Add Lines, is a common way of opening files. These are used for line scans and grid scans collected with any conquest system from our very first one introduced in 2001 until January 2016. So those are the ones you're going to use for older conquest systems. In January 2016, we released the Conquest 100 Enhanced system that outputs data to a file called a GPZ file, or a GPZ file for our American friends. If you have a Conquest 100 Enhanced system, you can use the top 2 options here to open the GPZ file. At this point, I'm going to open data in the way that most of you with earlier conquest systems will have to. Later, I will open a GPZ file. So let's start by opening a folder that contains conquest line scan data. So I'm going to go to Add All Lines in a Folder, navigate to the folder I want, and here's the folder that I have called Line Scans. So I'm going to select that folder, and it opens up. So this is the main screen of Echo Project. It consists of several windows that I will describe in detail. You will find that all the windows are related to other windows. Changing something in one window changes things in other windows. So the first thing I want to look at is way over here on the left-hand side is a little window called Project Explorer. Project Explorer lists all the GPR data in the project. GPR lines, GPR folders, and grid folders. I don't actually have a grid folder in here, but it will later on, you'll see that. And the idea behind this one is modeled on Windows Explorer. It allows us to open folders, we can collapse folders, we can select lines. We can also copy, cut, paste, and delete folders or lines. So for example, if I want to rename a file, I can do that. I click on it just like Windows Explorer. I can click on it, and I'm going to change the name of this one to Parking Lot Floor. So there I've changed the name of that file to something a bit more descriptive. So we select a line, a conquest line scan, by clicking on it. So any of the ones I click on are selected. Now I want you to also notice in Project Explorer, that there's a right-click menu. And right-clicking on anything opens up this sub-menu. We call it the Project Explorer menu. This provides a list of things that can be done to the line. For example, I can rename it, I could cut, copy, or delete it. And as you can see, there are many other options in this list, but I don't want to get into those details right now. Just remember that the right-click menu allows you to do many things. Next window is the line preview window. That's this one here that's actually showing some data. Now notice that when I select a line in Project Explorer, the line is immediately displayed in the line preview window. So everyone I click on in Project Explorer will immediately appear in the line preview. Now what I want you to note in here, the position axis is along the top and the depth axis is along the side. Notice the vertical exaggeration in the data. This line is more than 5 meters long, but only about 1 meter deep. This is very typical of GPR data, and we should always be aware of this. In short, it can make mountains out of molehills in the data. Since this line is a Conquest data line and Conquest collects PCD, that's the power cable detector, it collects that data as well as the GPR data. The line preview also includes the PCD response in red underneath the line. So we can see that in here. We actually see a little peak over here in this part of the section. And the scale of the PCD graph is shown in the legend below. So right now, the scale on this is 10,000 nanoteslas. So this is a very strong peak that's appearing in here. I also want to point out in Echo Project the toolbars. The toolbars at the top of Echo Project have buttons that allow you to do many things. For example, if I would like to change the units the line data is plotted in from meters to feet, I can simply click on the button called US Standard Units, and notice how the units have now changed in line preview. So now our American audience will know that this line is 16 feet long and about 3 feet deep. So I'm going to switch it back to meters. As you can see, there are many buttons in the toolbars, and you will learn what they all mean, but for right now, I just want to point out the ones that are most useful to us when looking at line scan data, namely the ones that allow us to change the size of the line preview image. These ones here, the zoom buttons. So right now, I have 5 meters of data squished onto this one screen. If I click on the zoom in button, it actually spreads the data horizontally. And so now I have a slider bar to see along it. So it's sort of like zooming into the data horizontally. So if I zoom in enough times, I end up seeing individual hyperbolas in this particular cross section. If you want to view the whole line in the window, click on this one called Fit to Window, and that will bring it back to where we were before, which was however long the line is, it will be shown in the one window. So that kind of squishes it right down onto one window. If I want to zoom into a particular part of the line, I can click on the Zoom Window button and then click and drag a box in the line preview window. So if I click here, then say I want to zoom into this part, I can click and drag and then zoom in on that particular area. Okay, we'll talk about the other buttons on the toolbar as we go. The next thing I want to show is the line property tabs. And that's over here on the right side of the screen. See over here, there's a series of tabs. And they're called Acquisition, Processing, and Attachments. So let's click on the Acquisition tab. The Acquisition tab lists the data acquisition parameters for the line currently selected in Project Explorer. So right now I've currently clicked on the parking lot floor line, and this is all the details about it. The original line name, when it was collected, the type of survey it was, the frequency that was used, the length of the line, the step size, all kinds of details. And if you scroll down, right down on the very bottom, all the details right down to the serial numbers of the units that were used to collect the data. The next tab is called Processing. The Processing tab lists all the processing that has been done to the line, things like filters or migration. In this case, we're not surprised that nothing has been done to this line. Processing is done under the Process button, which is right here on the toolbar. Conquest data does not typically need to be processed, so I will not be covering the details of the processing module in this webinar. So I'm just going to close that right now, and you can see that in another webinar if you're interested in processing details. The Attachment tab, the third one here, lists all the files that have been attached to the line scan. Things like photos, videos, documents, voice recordings, GPS, any file can be attached. This is very useful for documenting and archiving your project because any file you attached is permanently saved with your GPR project. So let's attach a photo that was taken when somebody was collecting this line scan. So what I'm going to do is go to the Add a Line line here, click on the 3-dotted button, and then I'm going to move in and I'm going to find the photo that I want to attach. And I think that's one right here. Here we go. And now it's attached. So notice that the name of the file that I attached is now listed in here. And we can open it. I can go over here, I can hit the drop down, and I can open it so you can actually see what that picture looks like. So that's the photo that I attached. Let me close that up. The other thing, as soon as you attach something to a line or a folder, you will actually see a paperclip appear. So over here in the parking lot floor file, we actually see a little paperclip which indicates that there has been a file attached to it. So that gives you enough for us to start analyzing the data. So let's have a look at the current Conquest line scans. So there are several ways to open a GPR line in the line view module. So if we want to look at the line in detail, we're going to use a module called line view. And so if I want to open it in line view, there's several ways to do that. You'll notice that when I select it, the line view button is now available on the toolbar. Or I can right click, I can go to the Project Explorer right click menu, and line view is available in there as well. So that's two ways. But I find the easiest way is more intuitive, is just if you want to open the line, just double click on it. And there. Now the line is open in line view. The line view opens and there's a new menu. So we've got another menu up here. We got some new toolbars. But you're going to see similarities with the toolbars in Echo Project and other modules. For example, the first thing we notice is that in this particular line, it's 29 meters long, or about 96 feet of data, all on one screen. So we probably want to zoom in horizontally. So we look for the zoom button, and we'll zoom in. I'll click on it twice. So now it doubles the length of the line twice. So now it's 4 times longer than it was originally. So now I have a slider bar. So if I slide to one end here, we can look at the data, and we can slide back and forth. Now what we see in here is what we would interpret as rebar or perhaps a wire mesh in this concrete floor. We'll also notice that it stops, and so the whole left-hand side of this cross-section doesn't appear to have any rebar in it. So that might actually be interesting information for your client to know that there's no rebar in a portion of his floor. Now, line view allows the user to open more than one GPR line at a time. So let's open a couple other lines and have a look at those. So I do that by going to the drop-down list up here, and when I click on that, it will list every GPR line currently in the project that I've opened. And so I'm going to open up, let me open up line 3. You'll see line 3 is now open. And I want to open up line 6. So now that all 3 GPR lines are open, we need to tile them on the screen. So there's 2 buttons here that allow us to tile. We can either tile vertically or we can tile horizontally. So in this particular case, I think I'm going to tile horizontally so I can see the long length of line. Okay, and what we notice is that the lines, actually, since we're looking at 3 lines at the same time, it makes sense to link them together so that when we zoom or scroll on one, we zoom or scroll all 3. We can do this by selecting the menu option View, and then going to the option called Link View Position Range. And when I click on that, you'll notice that the line lengths have changed. So let me scroll over here. And so when I scroll one, I scroll on the other. So let me change the zoom on this line here. Okay, and this shows you the relative length of each line. Line 2 here at the bottom is 29 meters long, and these other lines are about 11 meters and 10 meters. So you see the relative length of each line. So the other thing is when I start to scroll, so if I start to zoom, all of them zoom together. And if I scroll one, they all scroll together. So it's a very powerful way of looking at multiple lines at the same time. The other thing I can do is I might want to zoom in. So if I click on, again, the zoom window still works. So if I zoom in on, say, the first few meters, so if I zoom in on this window, all three windows zoom. So we're looking at the same data on all three lines. So it really is a great way of comparing parallel line scans. Now, when we're out collecting data, one of the things we might be asked is for a depth estimate of objects that we find with GPR. And most of you will know that a velocity calibration is very important if you're estimating the depth of objects. And specifically, to try to get our best calibration, we need to find a spot where the object was crossed at right angles, perpendicularly. So I'm going to look at this line here where I've got some nice hyperbolic features, and I'm going to zoom in on one of them. So let me go into the zoom in window, and I'm going to draw a box around that hyperbola. So now that zooms right in on that hyperbola, so I get a really good view of it. Now what I'm going to do is I'm going to click on the Hyperbola Velocity Calibration button on the toolbar. And that's this one, which actually is a picture of a hyperbola. And when I click on that, a red hyperbola appears on the screen. And so wherever I click, that hyperbola will jump to. So I'm going to take it, I'm going to click right on the top of the hyperbola and have a look at it there. Now you'll notice that the shape doesn't match very well in this case. We're off a bit. And that means that our current velocity that we're using is not correct. So any of the depths that we're taking from the current plot are off. So right now it looks like this object is on the order of about 34 centimeters deep or so when I look at this. But after I calibrate the data, so I'm going to grab the tail and I'm going to try to match it as best I can. So I think that's a pretty good fit. I can see it coming down in here on this side and this side, pretty parallel to this. So I think I've got a pretty good fit in here. And you'll notice the velocity is listed on the bottom of the screen here. So I've changed the velocity from 0.1 meters per nanosecond to 0.117. So we're getting close to a typical value that we get for concrete. Now, here's something I want you to notice. I'm not finished my calibration yet. To finish my calibration, I click on the hyperbola button again, and it's going to ask me a question. It's going to say, hey, you changed the velocity. Do you want to use the new velocity? Yes, I am going to say yes to that. But before I do, I want you to understand the effect of updating the velocity. The GPR image does not change. The only thing that changes is the depth scale on the left side of the image. So these numbers over here are going to change. So watch what happens when I click yes. I want you to watch the depth scale over here on the side. That is the only thing that changed. And so now that we've updated the depth scale with our new velocity, now we're a lot more confident in giving an estimate of the depth of this object. And so when I go over top here, I see that we're looking about 38, 39 centimeters down to the top of this object. So we're a lot more confident in that depth than we were before because we've done this calibration. Now, since we're looking at this line, and I'm going to zoom out, so we're zoomed right in on this one hyperbola. So I'm going to zoom out, fit to window, so there's the whole line in the window. And I want you to notice something in here, and that is the gain. The gain, or another way of putting it, is the amplification we apply to the GPR data is critical. It can make the difference between finding an object and not finding it. And you have a gain setting out in the field, but remember that sensors and software systems never apply gain to the raw data that's saved and transferred to a PC. This means that line view allows the user to apply a new and perhaps better gain than was applied out in the field. And this gives you the potential of seeing the more subtle reflections that you may not have seen out in the field. And these three buttons up in here are the ones responsible for the gain in line view. So right now, notice that this GPR line is auto-gained. And frankly, the auto-gain is doing a pretty good job in this case. But maybe we want to adjust the gain and try to gain a little bit better. So how do we do that? What I'm going to do is I'm going to change it from an auto-gain. I'm going to hit the drop down, and I'm going to change it from an auto-gain to a numbered gain. So I'm going to pick number 1. Now you're looking at it instantly applies a gain of 1 to the cross section. You see that gain of 1 is a bit too low. But now what's happened is because now I'm in a numbered gain, these buttons, the plus and minus gain buttons, are available to me. So what I'm going to do is I'm going to click on the plus gain button, and I'm going to go to gain of 2, gain of 3, gain of 4. And each time I click it, the gain increases a bit more. I continue to do this until I like the look of the data. So a gain of 5 is actually pretty good for this line. Okay, so let me switch to another line here. Okay. Now, I want to show you another thing that can clean up your data and emphasize hyperbolic responses from objects in the concrete and underneath the concrete. And this is called the Background Subtraction filter. And that's this button here, BKG-SUB, Background Subtraction. This filter is designed to remove flat-lying reflectors in the GPR line, which is usually a good thing because we're often looking for rebar and conduits, so we're way more interested in hyperbolas than flat lines. So watch what happens when I turn this filter on. And I do that simply by clicking the button. Let me flick it back and forth. You can see that all the flat-lying reflectors in the data have been filtered out. So you can see that this band coming through here at about 50 centimeters disappears, and the strong reflection at the top, which is actually the direct wave, gets filtered out. And that is what the background subtraction filter is for. I also want you to notice that all the hyperbolic events on here are not filtered out. And that's the whole reason for this filter. It's to remove the flat lying and emphasize the dipping events like hyperbolas. But I want you to notice something. The background subtraction filter also did a good job of removing this flat lying reflector. See that reflector there? If I turn the background subtraction on, you see that it gets filtered out quite a bit. What is this reflector? Well, let me tell you that this line was collected on a multi-level parking garage. So, do you know what this reflector is? It's the bottom of the concrete. It's actually the bottom of the suspended slab. So that might be something that we're interested in. So be very careful when using the background subtraction filter. It's designed to remove flat reflectors to emphasize hyperbolas from rebar and conduits. If you are interested in seeing things like the bottom of slab, do not use the background subtraction filter. So let me switch to another line here. Go back to this line that we were looking at, actually. Let me go to this line here. Okay, I think we were looking at this one a little bit earlier. Okay, I want you to notice something else. And I'm going to increase the gain a little bit just to make it really obvious. On the bottom of the section here, there's kind of a speckle. You see that in the background there? And so what is that? This is actually the background noise. And it is radio signals from other radio sources like radio stations and cell phones, TV stations, walkie-talkies, all sorts of other radio sources. Because remember that a GPR receiver does not just receive GPR signals. Not just GPR signals. It receives all radio signals in its bandwidth. So signals from other radio sources are collected and will be displayed in your data. It's very important to remember that they are not GPR signals and should not be interpreted as signal in the ground. So what the background noise is really good for is showing the maximum depth of GPR penetration at the survey site. The background noise is quite weak, so once we are seeing the noise at the bottom of the GPR line, we know that the GPR signal has been attenuated or absorbed by the soil or concrete so much that it has been reduced to the noise level. In this case, if we look at where the GPR signals are fading out, it's somewhere in this 80 to 90 centimeters is where we're starting to see the noise kick in. So if suddenly we see a reflector much deeper than that, we know to be suspicious of it. It could be a real reflector, it could be a real object in the subsurface, but we need to do some due diligence to confirm that and make sure that it's not a reflection from something in the air and it only looks like it's in the ground. Okay, let's leave line view and let's go back to Echo Project. And I do that by clicking on the big red X up in the corner. So that's a bit counterintuitive, but trust me, it's okay to do that. We're not losing anything by doing that. So we click, now we're back at Echo Project. There's one more thing I would like to show you about line scans before we move on. You may know that the longest line scan that you can collect and save with Conquest is about 6 meters or 21 feet long. So when you're using your Conquest system and it beeps when you're collecting a long line scan, that's what it's telling you. It's telling you that you've reached the maximum distance that you can save. But say you want to collect a longer line. What do? Well, just collect 2 or more line scans, save them, and use Echo Project to merge them together into one long line. So let's do that now. So if I look at the list here, I'll tell you that line 11 to line 14 were all collected consecutively. So we collected a line scan till it beeped, we stopped, we saved that, we collect the next line scan until it beeped, we stopped and we saved that, and so on. So what I'm going to do is I'm going to merge them all together. So I start that by I check them. If I'm going to merge them together, I have to check them. So I've checked all 4 lines here. Then I go to the option called Tools, the menu option Tools, and I go to the option called Merge Lines. When I open that up, it asks me to confirm the order that I want to merge them in. If I want to change the order of them, I can highlight one and move it up or down, but the order is correct the way I have it right now. The other thing it asks me to do is what's the name of the new line? And it offers the name merged line, but I'm going to put a bit more information in there. I'm going to put merged line 11 to 14, so when I'm looking at it later, I know what it's where it's from. So let me hit OK. I'm all ready to go. And what I want you to notice is now the new merged line appears in the list. I have this file called merged line 11 to 14. If I double click on that line, it opens up in line view. Now I see that this line is about 26 meters long, or if I quickly switch the units, it's about 85 feet long. And so this is a very long line, and there's no better way to see a reconnaissance line across a large concrete structure and to get the big picture than this. And what it allows you to do is look for large-scale patterns that might help our interpretation of the data. In this example, we notice this trough feature. So I notice a trough here at about 2 meters. I see another one at almost 4. Another one here, another one here. So this seems to be running periodically through the data. So my question is, well, how far apart are those? I can kind of eyeball it here, but why don't I measure it? So I can use the measure tool. So the measure button on the toolbar, I click on that, and then I can click and drag, and I can measure the distance. And so in the bottom corner here, it tells me that distance. So the distance there is about 1.84 meters. And if I measure the distance between these two, I can see that it's similar. And so there seems to be this periodic pattern of about every 1.8 meters or 6 feet or so. So this is useful information to know the structure of the concrete structure is like this. Okay, let's go back to Echo Project. Now you may have been wondering, we've been back and forth in Echo Project, you may have noticed this empty window here. This is the map view window. It's empty because there's nothing to display in map view. We have line scan data, but we don't know the positional relationship between any of these lines that are listed in the line scan. So they do not appear in the map view window. So let's add a grid scan. So let's add a grid scan so we have something to look at in map view. So where do I go to add more data to my project? Project Explorer, of course. You can use the Project Explorer toolbar or the right-click menu. So what I want to do is I'm going to right-click in here, and this time it says one of the options is add a line, or sorry, add a grid. That's exactly what I want to do. So I'm going to go into Add Grid. I'm going to find my folder, my grid folder. I'm going to open that up, and inside there's a GFP file. And a GFP file it's a file that contains the grid geometry, and that's the file that Echo Project opens. So I select that file, I open it up. Notice now we have something to see in map view, and that's my window. That's the map view window, that's the grid. So you'll notice that there's a local coordinate system. So this one is about 1.2 meters by 1.2 meters. If I actually change the units, this is a 4 foot by 4 foot conquest grid. That's what was collected. Also notice as well, since I brought the grid in, it's now listed over here in Project Explorer. So I have two folders in Project Explorer. I've got the grid that I just opened up, and I have the line scan folder that I was looking at earlier. Now I'm running out of real estate here. I've had to resort to using the scroll bar to see all the data I have. So I'm actually going to collapse down the line scan folder just so I can look at the grid scan folder. So these are the names of all the lines in my grid scan. X line A, X line B, and so on. Y lines 1, 2, 3, 4, 5. All the lines that you collected out in the field. Now I want you to notice the difference in a grid folder. A grid folder actually has a little picture of a grid on it. And so it differs from a line set folder. Okay, so grid folders are special, and we're going to see in a minute how we can treat those and why they're displayed differently. Now, again, back to the map view window. The map view window shows the data in a bird's eye view. In this case, it shows the grid lines for this 4 foot by 4 foot conquest grid. Now, when we see grids, we think, or we should think of depth slices, because that's the main reason why you collect data in a grid. As I mentioned before, grids are special data, and only grid data can be opened in a module called Slice View. And Slice View is the processing module for creating depth slices. And like Line View, there are several ways to open the Slice View module. I can click on the grid, and I can notice that the Slice View button is now available to me in the toolbar. I can right-click on the grid, and I notice I can pick Slice View from the right-click menu option, or what I think is the most intuitive way is to just double-click on the grid. And this opens the grid up in a module called Slice View. So I've got two windows here. I'm going to arrange those side by side. Now, Conquest users are going to be familiar with this type of data view. The image on the right is one of the grid lines. The image on the left is the grid. It shows the grid. You can actually see the lines of the grid that were collected. And it also shows the depth slices. That's the blue part in behind. So if I click on a grid line in the depth slice, it will instantly jump to that cross-sectional image. So when I click here, now I'm looking at that cross-sectional image and it appears in blue, in red here. So that's this cross-section. If I click somewhere else close to a line, now I'm looking at a different cross-sectional image. But it's always indicated by the red line across the depth slice. So I can also use the arrow keys to move, arrow keys on my keyboard to move up or down, left or right. And so this gives me a way of quickly scanning through the data, looking for interesting anomalies in a cross-sectional view. Now, the depth slice we're looking at currently on the left-hand side here is all the objects embedded in the concrete in the first inch or 25 millimeters of data. So in cross-section, it's all the data between these two red lines. So we can see that this depth slice is not very exciting. But we can see all the hyperbolas down here. So we know that when we move these red lines down into the hyperbolas, then we're going to see the more exciting data. So let's do that now. So to move down deeper in through the cross-section, I can click on this button, which will move me down through the cube of data and into the hyperbolas in this case. So when I slice down deeper, we can see the series of rebar. And so this pattern doesn't look, it's going to be nothing new for most of you. That's a typical rebar pattern. Now, one of the things is I'm not super happy with the gain on this particular cross-section here, or sorry, the depth slice. I'd like my rebar to be a bit brighter. So what I'm going to do is click on this window, on the depth slice window, so it has the focus, and then I'm going to go into the gain button, and I'm going to change it from auto to a numbered gain. And you'll notice again, a numbered gain of 1 isn't really doing much, but now I can gradually increase the gain using the plus gain button until I gain it up enough, and there. Gain of 6, I'm a lot happier with that. The rebar look a lot brighter, a lot easier to explain, and a lot easier to see. So now, let's slice a little bit deeper. So I come over here, I slice a bit deeper, and you'll notice in the next slice underneath the rebar, we see a strong feature running through horizontally. People who use GPR in concrete are going to instantly think conduit. So let's see if it might be a power cable by switching the depth slice view from a GPR data to PCD data. And I can do that by clicking on this window so it has the focus. And then you'll notice we have this lightning bolt button here, which is actually the PCD button. So what's going to happen is it's going to switch from a GPR image to the PCD image. And there it is. If I toggle back and forth, you can see how this PCD response appears to correlate pretty much exactly with this suspected conduit coming through here. So sure enough, there's a strong PCD response that corresponds with the conduit. Now I want you to notice that in this case, the PCD response looks like two objects. Looks like I've got one here and another one here. In fact, this is one conduit with wires carrying current in opposite directions. So the magnetic field cancels out in the middle. So what looks like 0 around here is actually where the conduit is running. And again, it's been canceled out, so it's essentially 0 at that point. And for those of you who've seen a lot of data, this is a typical PCD response because wires running through in different directions, you get constructive and destructive interference of the magnetic field, and so you can get some odd responses like this one. Okay, what I want to show you now is what happens when we leave the Slice View module and go back to Echo Project. So let me hit the big red X in the corner to exit out of the Slice View module. Again, it's perfectly fine to do that. Everything is saved. And we go back to Echo Project. Here you see that the depth slices that we just generated now appear in our map view window. So we also have a scroll bar here. So I can grab this scroll bar and I can slice down through and look at everything in my, through the depth slice sequence through the data. So I'd like to point out here that the depth slices in the map view window are automatically displayed if you have a Conquest 100 enhanced system and you process the depth slices out in the field. When you export the data to a memory stick, the depth slices are included. So when you copy the data to a PC and open the project file in Echo Project, the depth slices are instantly visible in map view. There's no need to do what we just did by going into the slice view step. But with older data that doesn't automatically, older Conquest systems that don't automatically generate the depth slices out in the field, you need the slice view module to generate those depth slices. Now is also a good time to talk about the one window in Echo Project that I have not talked about yet, and that's called the layer view window. This window has checkboxes that control the elements plotted in the map view window. In this case, when we look at the map view window, we might want to turn off the grid lines that are interfering with our view of the depth slices. So I can go in there and I can uncheck the lines and they disappear from in here. So now when I slide up and down through the data, I can see it much clearer. The other thing I might want to look at is the PCD response. So when I check on the PCD response, there it is. So I can toggle back and forth between the GPR data and the PCD response. So if I find that conduit and I turn the PCD response on and off, again, we can see that it lines up very well. Now notice on the grid scan, let's see, let me go to one of the lines on the grid scan here. So when I do this, so it appears in the line preview. When we look at one of these cross sections, we see that we've got, 3.3 feet of data, but the most interesting stuff is really in the upper foot or so. So one of the things we might want to do is cut off the data. Say a value of about, let's say about 1.6 feet or so would probably be enough to show all the most interesting stuff. So how do I do that? Well, to do this, I open up this line, one of the lines in the grid. I can double click on it, open it up in line view. Here it is in line view. And then I select the View Settings button, which is this one here with the slider knobs on it, the red, green, and blue slider knobs. Click on that. I then go over to the Limits tab, and I'm going to change the limit from the maximum to a depth of 1.6 feet. So I set it at 1.6, which is what I want. And then I also select, and this part is critical, I've got to select this checkbox that says apply to all lines in the line set, because I don't want to just do it to this line. I want to do it to all the lines in the grid. So when I click on OK, you'll notice that the data is replotted, and now the vertical scale is only 1.6 feet. So I've essentially zoomed in on the top portion of the data. So now when I exit from line view and go back to Echo Project, the depth scale is updated in here. So now it's only down to 1.6 feet, where all the interesting stuff is. Okay, I want to show you another Echo Project window that's not currently open, and it's called the 3D Preview window. Again, grids are special in Echo Project, and Conquest grids are even more special. When I select a Conquest grid in Project Explorer, notice that this button called 3D Preview is now available. I can also see it if I right-click, 3D Preview. So when I select that, another window opens. Now, this usually results in real estate issues. So what I'm going to do is I'm going to minimize the line preview, and I'm going to minimize the map view, and I'm going to maximize the 3D preview window. Now, this shows a data view that Conquest users will be very familiar with. a depth slice on the top left with red crosshairs superimposed and two grid lines displayed on the top right and the bottom left corresponding to the red lines. So this red line here is this cross section. This vertical red line is this cross section. Anywhere I click in the depth slice, it will instantly jump to the two closest cross sections to the point that I clicked at. Or I can move through the lines using the arrow keys on my keyboard. This is a wonderful way of having a look through the data quickly. So again, if I do this in the vertical or horizontal direction. I also have, you'll notice, a slider bar. So the slider bar allows me to move up and down through the depth slices at different levels. So what you're seeing is there's lots of ways of displaying your conquest data. Now, let's talk about generating a report. If our client is interested in receiving a report about the survey work we did with Conquest, Echo Project provides a simple means of doing that. Notice on the Echo Project toolbar, there's a button called Save View, and it's always this little green one here. And what Save View does, it will save an image of the data in the current window that you have selected, and it will attach that to the project. So for example, let's save the current image in 3D Preview. This looks like a pretty nice image. I click Save View, and it offers a name. It says, okay, the name of the grid and the depth slice. That sounds good. I'm going to use that name. Okay, that image has now been attached to my project. So let's open the line preview. So let me go to another one of the lines here. Let me open the map view window, and let me find this image, maybe of the conduit. And again, I'm going to hit Save Image, and it offers a name, and I say OK, and it saved that image. And now the last one I want to look at is the line preview. So let me open up the line preview. Let's find a nice line from the grid. Maybe I like this one. Let me move through and see if I can find something a little bit more interesting. I can show one that also shows the peak PCD response. So maybe this one is a good one. So I'm going to hit Save View, and it's going to save that view and again attach it to my project. So what I'm doing is I'm saving the images that I might want to include in a report for my client about the work I did. And to do that, I click on this thing called Gpr Summary Report. So there's a button up here on the toolbar called Gpr Summary Report. Notice what happens. This opens up thumbnails of all the images I attached to my project. Remember a while ago when I attached the photo? Well, that's there. And then the image from the 3D preview, the image from map view, and the image from line preview. Those are all saved on here, and they're all available to be included in my report. So in this case, I'm going to select all of them, and when I select them, they appear down here. Now this gives me the opportunity to change the order. So I might decide, well, yeah, I want to show a photo of me collecting the data, and then I want to show a typical cross-sectional image, and then I want to show a plan view, and then I'll show the 3D preview as the last image. So once I'm done setting up the order, then I can generate a report. I click on the Generate Report button. Now this screen allows me to add text to my report, including I can add, for example, client information in here. I can add as much information as I want on the site description, additional comments, and when I scroll down, all the information about each of the images, I can fill in information under the figures. Okay, so I can add my insights into the report. When I'm done adding all the information to the report, and of course one of the things I'm going to want to do as well is put my company logo in. And so up here in the corner, I can click on this and open my company logo. Okay, so if I click on that, now my company's logo is going to appear in the report. When I'm all done, I can hit save, and my report is saved as a PDF. So I'm going to save that report. Now it will open up, and here's my GPR Summary Report. There's not a lot of text in it because I didn't add an awful lot, but you can see that each of the images that I saved are now saved in my report. And it's instantly made into a PDF. So the objective is to add your insights into the images that you include in the report and get that to your client quickly. They are happy and you get paid. It's a win-win situation. Okay, let me close down the report. And let's go back to Echo Project. Okay, so we are now done looking at the data in this particular project. The good news is that when you go to leave Echo Project, it asks you if you want to save your data to a GPZ file or a GPZ file. So for example, if I click on here, it's going to say, hey, wait a minute, do you want to save? And yes, of course I do. And what I am saving is I'm saving all the work that I did. And so everything that we did, adjusting the gain, the velocity calibration, attaching photos, saving images, all that information gets saved to the GPZ file. So the next time you open it, you're right where you left off. Okay, so I'm going to save this file. Okay. Now, the very last thing I want to show you is perhaps something you've never tried before with your Conquest system. I'm going to open another data set, and this time it's a data set that's already in a GPZ file. So let me click on New, and this time I'm going to browse for a project, and here it is. It's called this one, Chicago Workshop, so I'm going to open that. So it unpacks, and instantly we see all the data, all the lines appear. In Project Explorer, we get a view of the grids in map view, and I see one of the cross-sectional images in line preview. So you'll notice here that this actually consists of 4 grids. If I collapse this down, there's a lot of lines here listed in Project Explorer. So I'm going to collapse them all down into their folders, and you can see that what I have is 4 grids. The 4 grids are displayed in map view, but they are all piled on top of one another, so I can't see them. So these grids were collected in the same room in a row, but slightly offset from one another. And what I want to do is show you a photograph of how these grids were collected. So this is a 4-foot by 4-foot grid, and then the next one over here, you see it's attached, but it's offset a little bit. So each of these grids are offset from one another. And what we want to do is we want to display them the way they were collected. So what am I going to do? What I'm going to do now is move each grid to its correct position with respect to the other grids. And I do that by clicking on a folder, and then, you guessed it, right-clicking in the Project Explorer window. So I'm going to click on grid number 1, right-click, and I'm going to select this option called Position Relationship, and I'm going to go into the wizard. And what I'm doing is I'm moving the 0, 0 corner of my grid to a new position in the project space. So out in the field, they gave me the coordinates. So this grid is going to actually move to the x equals 2, y equals 4 position. And I say next, and then I say finish. And there, you see that the second grid has been moved. Now I'm going to click on grid number 2, and I'm going to do the same thing. go to the position relationship wizard. And this one, again, this is what somebody marked down in the field. They said, okay, this one is at X position 3 and Y position 8. And I click next, and I finish, and boom, now it's there. Now there's one last grid, and that is this one here. So I right-click on this, I go to Position Relationship Wizard, and this time I got to move it to X equals 5, Y equals 12. Hit next and finish. So there's my 4 grids. So once I'm all done, I can go into the layer view and I can turn off the lines, and then I can use my slice to slice through the data. All 4 grids simultaneously. So this is a very powerful way of looking at your data. And I can also flip over to the PCD view. So we actually see, we can see this feature running through here, this linear feature that runs through. And if we turn on the PCD response, well, guess what? It's a power cable. So there's a power cable running through the floor. We detect it with the PCD detector, the PCD, and we also see it in the GPR data. So if you think about this, this opens up all kinds of possibilities for making better, more detailed, and easier to understand reports for your client. We have had Conquest users combine 20 or more grids together and slice through them at once to reveal larger embedded features not visible in smaller grids. So hopefully this gets you thinking about ways to provide more to your customers. So that completes today's webinar. Thanks for listening and have a great day.